Alright, today we're going to be talking about the start of our factoring unit, GCFs. Now, GCF stands for greatest common factor. So the greatest thing that multiplies into two or more numbers. So if you look at these first two things here, we've got 12 and 4. What I always suggest you do is always see if the lower number divides into the higher number. In this case, it does. So if the lower one goes into the higher one, then your greatest common factor is the lower one, 4. Because 4 goes into 4 and 4 goes into 12. Now, when you have variables, here's what you need to do. You need to basically write them out. X to the 4th in expanded form means 4 of them. X squared means 2 of them. So how many x's do those have in common? At most, you can multiply those 2 x's. So x squared would be the greatest x's they have in common. Now you can combine your numbers and your variables like these do. So when I'm looking at it, again, always try your smallest number into your largest. Does 3 go into 27? And yes, it does. So you already found that part of your GCF. But also I can see that they have some x's in common because they both have x's. So that first one has 5 of them, and the 27 only has 1. So the amount of x's they have in common is 1. So it always ends up being your lowest exponent is the amount they have in common. So let's throw a little bit more in there. Sorry about that bell ringing. So now I've got 10 and 25, so I'm going to start right here with our numbers. Does 10 go into 25? No. So this is the first one where that didn't work. So instead, let's think of our factors of our lowest number. Usually the lowest one's the easiest to start with because it usually has less factors. So let's think of that. We've got 5 and 2. So of those two factors, those are both prime, so we've taken it all the way down. Does your larger one go into it? Again, we're looking for the greatest thing, so we always want to start up as high as we can. We tried 10 first, and now we're breaking it down to 5 and 2, so we're going to go to the next biggest one, 5, and see if it goes into 25. And it does. So we've got 5 and 25, or sorry, 10 and 25 are both divisible by 5, the biggest number that goes into both of them. Alright, now let's take a look at these exponents. I've got 2 x's and a y for the first one. I've got 3 x's and 4 y's for the second one. So they have 2 x's in common and 1 y. So it always is your lowest exponent amount. So the lowest amount of x's I have is 2. The lowest amount of y's I have is 1 right there. So there's your GCF. Now here's where we're going with it. I'm going to give you a polynomial. Might be a binomial like this one. Might be a trinomial. I could make it bigger than a trinomial if I wanted to. Usually doesn't get bigger than 4 terms. But what we are going to do is figure out what the GCF is. We're going to basically pull that out, so divide it out, because a GCF, the F stands for factor, that's what multiplies into it. So we're going to take out that multiplication. And then once we take it out, we're going to write what our factors are. What 2 things did we pull out of that polynomial that when you multiply them together actually give you back your original polynomial. Sounds complicated, it's not. Let's try it. So 12x and 18. So right off the bat, I see that they don't both have x's, so x cannot be a GCF. But 12 and 18, let's see, does 12 go into 18? No. Break that down a little bit further. 6 and 2, does 6 go into 18? Yes, it does. So 6 is our GCF. So we've got a GCF of 6. Now, once I know what that GCF is, again, I'm going to divide it out of that. So we're going to take our original polynomial. You'll start doing a lot of this in your head, and you're going to divide out the 6 from every term. And when I divide that out, I get a 2x from that first part, and I get a 3 from that second part. Positive 3, right? So what's left over is 2x plus 3. So now what my factors are. So if I asked you to factor this polynomial by pulling out a GCF, you would tell me the GCF, 6, that's what you pulled out, and what's left over after you pull that out, 2x plus 3. So again, what are factors? Factors are the 2 things you multiply together. We're going to get up to the point where there's actually 3 things that we find. But right now, the 2 things you multiply together to get that original polynomial. And you can always check your work by multiplying. So if you want to check your work, you take that first thing and you distribute it back out. So 6 times 2x is 12x. 6 times 3 is 18. There you go. You've broken it down, and now you've checked it that you got the original polynomial. Okay, let's try another one of those and see how it goes. So a little more complicated. I've got, actually I've only got a 1 over here, so there's really no number to pull out of this. But I have 4 x's, 1 x, and 2 x's. So if I have 4 x's, 1x, and 2x's. How many x's do they all have in common? Well, they all have at least 1 to give. So your GCF is x. So what's left over after I pull out that GCF? Well, let's take a look. If I take away 1x from each of these, looks like division, just like this. Again, you'll start doing this in your head without even thinking. If I take away 1x from 4, then I have 3 of them. If I take away this x, I don't have any left, I just have the 2. And if I have 2x's, take away 1, then I only have 1x left over. So the factors are your GCF, x, goes on the outside. And on the inside, what's left over, this trinomial in this case. If you want to write this absolutely correct, you should write it in descending order, meaning your variables, their exponents should start big and they should go small. So really, I should have written this with my negative 4x next and then my positive 2. Now that's a proper trinomial right there. I would have accepted this answer as well though too, because they put it in that order. Alright, let's try another example. We've got 9x cubed, negative 3x squared, and 6x. Let's try our smallest number and see if it goes into the other two. So does 3 go into 9 and 3 go into 6? Yes, it does. Now let's check out those variables. I've got 3x's here, 2 of them in this one, and 1 of them here. So how many do they all have at least? They all have at least 1x. So what's left over when I pull that out? Are you ready to try this in your head? If you need to show the division like this and break it up individually, you can. But we're going to try it all in our head. So if I divide 9x cubed by 3x, then I have a 3 left over and 2x's because I took 1 out. I'm going to take out, what's negative 3 divided by 3? That's negative 1. And then you had 2x's, you take 1 away, you only have 1 left. Now notice I didn't actually write my ninja here. You can write it or not, that's up to you. Alright, next thing I have the 6x is positive 6x. So positive 6 divided by 3 is 2, positive 2. And then I had an x, took it away, so I have none of them anymore. How did you do without writing the division? If you need to, go back. You can show that step. That's fine. If you're right here with me, being able to fill it out right in a row, that's great. That's where I want you to be before we start our big factoring unit. So I've got my GCF, and in parentheses, what's left over when you take it out? 3x squared minus x plus 2. Do you remember what I said about how to check this? So if you want to make sure that you did that absolutely correctly, all you have to do is go and distribute it again. Remember, factors are just two things that multiply to that polynomial. So if these two multiply back together to that polynomial, you did it right. 3 times 3 is 9. 1x and 2 make 3. 3 times that negative 1 is negative 3. Got an x there, that's 2 of them. 3 times 2 is 6, positive 6. And you got to give it out an x. Did we get the same thing? Yes, we did. We did it correctly then. Alright, let's try another one. Ooh, got a lot of stuff going on here. It's a binomial, but it has 2 variables. So first off, GCF, let's try those numbers out. Always start with your numbers. It's easiest to start there. If I have a smaller 2 here, does it go into 6? Yes, it does. That's usually the case. Rarely does that not happen. Another thing I want to point out, even though there's a negative right here, don't worry about that. Only ever pull out a negative if it was the leading thing. So if there's a negative in the first spot, that's when you should pull out a negative. Otherwise, leave it alone. Now let's take a look at these variables. I've got 2 A's and 5 B's. And then on this other one, I have an A and 2 B's. So how many do they have in common? They have an A and 2 B's in common. So our GCF is 2AB squared. So what's left over when I take that out? Let's try it out. Here we go. 6 divided by 2 is 3. Had 2 A's, took 1 away, have 1 left. Had 5 B's, took 2 away, have 3 left. Negative 2 divided by 2 is negative 1. Had an A, took away an A, none. Had 2 B's, took away 2 B's. So suddenly we do have to write our ninja 1 because of this negative 2 divided by this 2. Because I have nothing else there to talk about. Got to talk about that coefficient instead. Alright, factors are then, put it all together. Your GCF in front, and your 3AB cubed minus your 1 left over. Again, those 2 factors are the 2 things you multiplied together to get out that polynomial.